Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your ever-present host of the Db2Night Show, and we're on to show number Z128, 128 shows of Db2 on Z and 246 shows on Db2 for LUW. So we've been doing a lot of shows through the years. And our special guest today is Francis Villafuerte from the IBM Silicon Valley Lab. How are you today, Francis?
Good, I'm good, thank you.
Good. All right, well, let's kick this off. We've got some wonderful things to talk about. I think this is, if I add everything up, I'm now looking at this is probably about the 17th or 18th new release or version of Db2 I've done for ZOS. Seeing as I started on 1.1, that would mean 1.23, 2.123, and then every version thereafter was only singles. But there we go. So let's go through and get this stuff going. As we'll go through our standard housekeeping things. Replays are available on YouTube now if you like, or you can find them off our replay blog on the Db2 on DBI Software's website, as always. I'm hoping, and I haven't asked Francis yet, but I'll put her on the spot and ask if she'll be gracious enough to supply a PDF of her slides, because our audience is getting likes to have that. That would be fantastic if you can.
Okay, yes, I will do it after.
Perfect. And we'll be able to download the show or listen to it on YouTube. And we also put our announcements with a hashtag of Db2Night on Twitter.
Okay.
And what we also have is the our disclaimer, which is copyright letting people know about copyrights. We respect them, and all the other things that go on with the show in terms of copyrights of the show and copyrights and trademarks of other people. So there you go. You can read that if you like. Other quick announcements. This is our final show of season 13, so we're going into summer break. You'll find me available eventually on email or something like that, but I plan to spend some quality time outside this summer around the pool. And if you are looking to take in a conference, iDoug North America is going both virtually and in person in Boston in the middle of July 11th to 14th. So if you're if you can make that conference, that'd be a good one to attend. Also, iDoug Edinburgh is in October in Scotland. I'm not going to Boston. I chose to give that conference a miss this year for about the first time, and I don't know how long, but I won't be there, but I'll be in Edinburgh. They've asked me to speak over there, and I'm looking forward to that trip in the fall. As always, our founding sponsor of the Db2Night Show is DBI Software, and they brought out a new Performance Web Suite version 7, available for Db2 and SQL Server, and you can find more information on that on their products page on their website, and that information is there. So if you're interested in Db2 LUW performance, you'd want to look into that. Our winner from last week was Charles Ullery of Burlington Northern Santa Fe Railway. And congratulations to Charles, and Amazon gift certificate, I believe, has already been sent to you. Now, I mentioned that Charlie, our original sponsor of the Db2, or co-host of the Db2Night Show in my house, passed at Christmas time, and we've now got 2 rescue chihuahuas. They were sent up to us from Texas. There's quite an industry in bringing in rescue dogs to the Toronto area, simply because we're a big enough city. We didn't have enough dogs to go around during the pandemic, and this is one of our 2 rescue chihuahuas from that. Lacey's found a chair and decided this is how she wanted to sleep. Thing with comedy is if you have dogs in the house, it's pretty easy to find a dog doing something that looks a little strange or humorous, and so here's Lacey having a nap. These guys just make us smile all day. They're just so fun and loving. All right, and here's our sponsor page again. Thanks to DBI. Thanks to Martin Hubel, oh, that's me, for sponsoring the show and making this happen, providing free education to the DB2 community. And with that, whoops, we're on to our polls. And today we have 4 polls for you to answer. Some of these are the standard things that we like to get people to go through. What version of DB2 are you currently running? Just because you're running some of the older stuff, it doesn't mean DB2 isn't important to you. It means that you're probably so dependent upon it, it's hard to find time to upgrade. We're getting the answers in on those. I think almost all questions today allow you to select multiple answers. And I'm going to, well, everybody's voted, so I'll close that off and share the result. And it's very good to report that virtually no one is still on DB2 version 11 of our audience today. No one's on version 11 compatibility mode. That's good news. Let's hide that and move on to our next question. This is just the, this one you only get one answer because there's only one you. So just looking at the experience of our good-looking audience here. I'm looking to see if we have any, the number of people coming into the industry, because I know people like myself, this year is 37 years with DB2 on Z for me. When I started, it was DB2 on MVS 370, because we didn't even have a requirement before DB2 to go on to XA back in those days. After putting in DB2, of course, we had a big requirement to be on XA. But again, we've got a very experienced audience again today, where 75% of our audience or thereabouts is 20 years plus experience with DB2. I remember seeing all of those faces through the years. And when do you plan to go to DB2 version 13? It's the same question we had last week, and this will be interesting to see how people vote. Thanks for voting quickly today. Everybody seems to be really in the mood for polls today, and that's just great. And we'll close that off because that gives a good idea of what's going on. Some want it this year, most want it next year, and there will be people after that simply because of timing and resources to be able to get to version 13. So we'll hide that. And the last question we have before Francis takes over is something related to the show today. And this is talking about which table spaces you currently have. And in the perfect world, everyone would be 100% on UTS, either PBR or PBG. But there's some old stuff hanging around that's just too good to move or too important to move. And so there's still some stuff hanging out there. So interesting to see this in terms of people voting. Okay, I think we've gotten to the point that people have voted if they're going to. Everybody's got some UTS. Yes, that's great. It's been around for what, 10 years now?
Since version 9.
Yep, that's about DB2 version, or 2007, 2008. So 14, 15 years. Some segmented still, some classic partitioning, some simple table spaces. Oh my goodness. We've been trying to get rid of those since what? When did segmented table spaces come out? In DB2 2.1. We've been trying to get rid of simple table spaces and segmented table spaces, and now segmented table spaces are old. Surprise! It's only been 30 years in existence, so that's fun to know. All right, with that, I'll move along here, and Francis, you're up. And as I said, and just to warn the audience, Francis has a lot of material. I mean, you normally find that with any new version presentation. So It does mean that there's a chance she'll run past the top of the hour. I'm expecting that. So with that in mind, if you've got a sandwich or something you want to start eating, if you're on the East Coast like me, I can understand that. So, but take it away, Francis. There is a question and answer tool we use in GoToWebinar. I'll be monitoring that. People can type in their questions, and at an appropriate point, I'll break in and ask those questions to you. So don't worry about that. In the meantime, I'll mute myself so I don't disturb you.
Oh, okay, great. Can you see my screen?
Well, you're all set to go. It looks
okay, great.
Thank you.
Thank you. Hi, everyone. My name is Francis B.F. Forte. I'm from the DB2 development side, and which is in the DB2 core engine area. Welcome to this section. In the next hour or so, we will look at some of the features delivered in DB2.13 for ZOS in the area of availability, efficiency, and application stability. Whoa, whoa, whoa. If you haven't heard or you missed the announcement, DB2.13 for ZOS was GA on May 31st, 2022, just a couple of weeks ago. DB2 has not have a deliver in the new releases boundary for many years. Since version 12, we introduced a continuous delivery model. In 13, beside the new feature that we delivered, we also built some foundations that are feature enhancements, such as internal control block expansion and so on. So that will make us easier to develop new feature in the field, and it's something that normally we don't deliver in the APOC streams. So today we are just going to talk about 3 main topics. Here's the agenda. Before I'm going on and doing the 3 different main topics, I thought I would quickly review over universal tablespace, especially the abbreviation and terminology, just to remind everyone. And then we're going to look into the lesson that we learned about PPG in the field and what we have done in version 13. And then we'll talk about table conversion. I'm so glad that everyone's still already using universal tablespace, and we introduced that in version 9. But then I see some people still using simple and multiple segments in the tablespace. So let's take a look at how you can easily convert those. And then at the end, we're going to talk about application management. So before we go on, just quickly review all the terminology. So partition-by-growth is PPG. You probably know by now because you're all using universal tablespace. It is designed to replace segmented and to lift the 64 gig segment tablespace limitations. It doesn't have partitioning key. And then what we've seen in the field, which we're going to talk about a little bit more, is that in the early ages of converting segmented to PPG, and since PPG can grow easily, some of the customer that we've seen is PPG tablespace. It's growing so big. And some of those extra large tablespace probably will be better performance using a partition-by-range. So partition-by-range in UTS, we abbreviate to PBR-UTS. It's pretty much similar of the classic partitions, so you're probably very familiar with that. In version 12, we introduced that PBR-RPN, that's partition-by-range relative page number. It's similar to what partition-by-range is. The only difference is that we make it more better and flexible for the scalability and usability. The reason being that every partition you can define the size differently. So for the case that maybe one partition you need more space and one partition you don't need as much space, you can alter and adjust accordingly. So we lift the partition size limitation. One thing I want to point out is that DB2 future strategic range partition tablespace is going to be PBR-RPN. So because of that PBR-RPN will be our future direction, we also look at what we can improve in version 13. So if you remember that in version 12, when we introduced PBR-RPN, we also introduced a ZPROM, set page numbering in ZPROM. In version 12, the default is absolute. That's mean just regular PBR UTS. And if you create a new table space, that's what the default table space is going to be. And then you can also choose relative if at the version 12. When we come to version 13, we change that default to be relative now. So that means once you migrated to version 13 in M100, if you don't specify anything on your DDL to tell whether you want absolute or relative, then now the new table PBR table space will be PBR RPM. And beside that, the change, we also look what performance can we improve on RPM, because PBR RPM tended to be intentions to be a bigger in data size. So we will make sure that anything that we can do right at this point that we are aware of, we need to enhance on. So performance improvement version 13 is to improve our locking hash values. So every time you lock on page and partitions, then we will make sure that the value doesn't give you that false contention, especially for row-level locking. So those are quick review over what we talk about and what we can have on the UTS. So now let's move on to look at what we have learned in the field about partition by growth, and also what we done in the version 12 that to improve availability performance for PBG. So if you remember, I just talked earlier that DB2 introduced PBG to replace segmented table space. And one of the main design rationale behind it is to solve the 64 size limitation of segmented table space. However, what we have seen is that customer converted to PBG, and because they need that greater than 64 gig size. And with the business environment changes, then PBG table space has grown rapidly. When PBG table space grow too large, DBA usually have a great challenge to tune those concurrent applications to run in with a great performance, especially if you have volume insert applications running concurrently. Those large data size of PBG table space could have a better performance if you can managing the size in this fashion of like range partitions. So either using PBR RTS or you're using PBR RPM. So we talk about this and how you convert that a little bit more later. But the reason being is that if you have multiple partition and the only index you have is on the entire whole table, so is non-partitioning index, you will have to search every partition to figure out where to put the row. And it also depends on how your insert application accessing the data and also your query accessing data, right? So either you insert in sequential clustering index order or you can random. So it depends on how it is when you have multiple partitions. The difference with range partitions that you can managing that to be in a certain range and we're only accessing that partition at once. It doesn't go other partition to search for. So this is what the difference is between if you're using large PBG or you're using smaller set size of PBRs. I mean, not set size, the data sets of PBRs. And we can talk about this more when I have a better examples. So other things that we learn from the customer in the field is that sometimes they see that insert application that into this PBG table space. Those applications will terminate prematurely, and they're not sure that why it's terminated prematurely. Supposedly that they should have enough room to insert this rows, and when the application terminate prematurely, what the message they will see is resource not available, and then they will get reason code like, for example, conditional lock failure, or maybe partition in the PBG table space are full. So if you're gonna look at that and say, okay, if I get the message of C9009C saying partition, all the space on the table space is full, you go back and you look at your catalog table, you look at this cat. It's like, well, I still have many partitions that have available space. So why you're saying me, while DB2 is telling that failing with the C9009C. So those are uncomprehensive of the message that you tell customer doesn't give a very good reason why the failure is there. And DBA is not very easy to managing the space reuse also. That some of the DBA tell us that it's real difficult to tell where the row is going to go and then into the partition, and they would like to managing the space a little bit more. And we're going to show the example about that, why is like that and what situation that you see. As PPG grow too big, even though data is gathering physically in the partition size, but if you think about it logically, there's really no range of each partitions, and it's basically on this non-partition MPI index. And so the record, it's real hard to determine where which partition is records in externally. So logically, it is a linear data set. And because of that, there's some unpredictable performance side effect when you have so many partitions that you need to search through. So we will talk about that example, and so you will probably getting better idea of what I'm trying to say. So with all this lesson that we learned, we went in the version 13, and we're trying to address some of these concerns that from customers. And that's now we're going to take a look what we've done in version 13. So before we can talk about what kind of other issues behind this PPG for the insert applications, we will have to look at what this cross-partition behavior is for when we start doing an insert, and what's the cross-partition search it's all about. So a quick review of universal tablespace locking hierarchy. It's so different from segmented tablespace, and it's very simple. It's just like, in order for you to access the data, we need to get certain lock, and the lock hierarchy is get the partition first, and then once you get the partition, you get into the page, you either get row locking or page locking. So following the locking hierarchy, partition lock is required before we accessing any data to the partition, right? So when PPG tablespace has multiple partitions, to avoid the contention of the lock on one partition, so all the thread comes in, for example, you have index all going there, you coming in, so we're all fighting for that same partition. And maybe on the other same time, you have other application running on this object and using different lock, incompatible lock for maybe query, for maybe update, or maybe you're locking a table, or maybe lock escalation. For all that, try to avoid that contention. And then there's many other partitions that we can search to insert. So we don't need to be stubborn so much that that is the partition that I need to get into to get that row into. So for performance reason, we will ask the partition lock to be conditional. If we can get in, we got the conditional lock acquired successfully, then the partition is searched for the space to insert. If the conditional part lock was not successfully acquired, then the partition is skipped because we have other to look for. Why need to be stating on this and waiting for that lock, and then eventually you'll time out about? Because then depends on your timeout ZPUM setting, you may be taking longer just to move on, right? So once we move on to the next partition and we do the similar thing, we get the partition lock and then we get the row lock if we need to. So the cross-partition search only search through all the partition on your table space at one time, right, prior to the 13. So the partition is either that we searched and we either find a space in there, or we couldn't find a space in there. Or maybe it is skipped because we couldn't get the conditional lock to get into the partition. So at the end result, that's where you're gonna get all this -904, and it depends on what was the last message or last the optical that we encounter and insert. You either get C9090 to say, well, we couldn't get a partition to get into this partitional lock to get into this partition. So that's what you're going to get on the message reason code. And or you say, I search everything, I couldn't get it. And last partition I searched is partition is 4, so now you get the C9009C. So the error message usually just indicate what is the last article that this search, the partition that we encounter. If the last partition search happened to be 4, then you get that. If not, then you'll get something else. So let's look at some of the examples that we have. So assuming this table, PPG table space, we have 5 partitions. As you can see, the solid blue meaning the partition is 4, and the partition 4, we have some space. So as insert starts, we, based on the cluster index, we say, okay, well, based on the cluster index, the partition 3 is the best partition to go to and put your row in, right? So we get into partition 3, unfortunately, it's full. So we were going to move on to partition 4. But at this time, when we go to the partition 4, we fail on the conditional lock failure. Even though it has a lot of space, but we couldn't get into the partition, we will not be able to know what there's free space in there. Then we move on to partition 5. Once we move on to partition 5, we still couldn't get in because we have a conditional lock failure. We're going to move on to partition 1 and 2 because we know that we only search 3, 4, 5, and then we're going to search 1 and 2. But at this time, 1 and 2 are both full, so that's why the last partition we search is partition 2, and it's full. So that's why you're going to get resource not available. And so this is why I mentioned it earlier, that if you have a lot of those partitions, this is behavior just going to continue until we can find something to insert the row, right? So in this example here, the conditional part lock failure could be the reason of the application terminated prematurely. It's not really the partition 1, 2 is 4. It's like you have partition 4, it has a free space, but because we move on to the next partition and search, partition 4 never been searched, and that's why you get the message like that. And so actually, if we can get in partition 4 to search that partition, then you probably will be successful to insert that row. So that's why I meant that this message doesn't provide external user that really a good information that what kind of follow-up option that you can have, right? So let's move on, and we're gonna see what we have done in version 13 to help this situation. In version 13, the first step is to retry the partition that failed with the conditional lock failure the first time. So the idea behind it is basically say that it's, at the moment that you're trying to accessing the partition 4, maybe you fail with conditional lock, but perhaps by the time if we retry again, then the blocker of that thread that blocking that partition lock maybe already gone away, maybe committed gone away. So then if we retry, we'll have possibly get into partition 4 again. So in that case, it will be good to find a space. But we also don't want to be lingering retry this over and over and over again and just infinity and prolong your application to run so longer than you want it to be. So when we retry the failing partition, there's optimization in place to determine that when we attempt to retry again, do we want to do conditional lock conditional lock again, or do we want to do unconditional? For example, in this case that we fail on partition 4. So we fail on the partition 4, then we know that we're going to retry partition 4, and we're going to retry partition 5 because in the first pass around, we know that we fail on both of them. So in this case, in just an example, so does it make sense that I try partition 4? So if we retry time, and then we find out that, oh, the partition is already full, we actually don't need to go in the partition 4 anymore. So those are kind of optimization that I was talking about. And then even though partition 4 is not full, we can look at the partition 5. Is it full or not full? And then if I have one more partition to try, if I couldn't get it on conditional lock failure, then we can just move on. So just some of the examples, some of the optimization that we put in it's very complicated logic that we put it in. We also utilize RTS information to help us to make this information to determine that. So if we try part 4 and we try part 5, and we could, part 4 now it's full, we have to try part 5, and then part 5 is the only one that we try. So this time that we're gonna try part 5, we're gonna make sure that we're not gonna get unconditional, we're not gonna get conditional lock failure again. So this time we will get unconditional lock for the part 5, because that's the only chance we have before we fail the application. We need to get in and try to see if we can insert the row. So to avoid that, what I said earlier, that we're waiting for a long time, because the lock time are waiting based on your ZPROM, we don't want to have this insert application holding this, waiting for this lock for a long time, and could be everything else is behind it and slow down in the system. So when this time we're asking for unconditional lock, we're only gonna wait for 1 or 2 seconds. We're gonna override your system IRLM timeout ZPROM value, and we're gonna wait for up to 2 seconds. And if it still fails, because just in case there's other application that already caused this partition to be lock escalated or something, we're waiting for that lock to release, you will see the message now. This time around, you will see the timeout message opposed to conditional lock failure message. Because on this timeout message, GSNT 376, you will see who's your holder of the blocker of your insert application, and also going to tell you the value, how long we waited for. So in here, you don't have to wonder, say, hey, my timeout value is 60 seconds. How come you didn't wait for 60 seconds? Only 2 seconds you already fell out on this application. So we'll tell you the message is like, what is my timeout value that we override from your IRLM. So that way will give you an idea that what exactly the real issue is, and you can take the follow-up actions. Throughout our internal testing and our sponsor user for this particular improvement, they found that the enhancement increased higher insert successful rate. So now it used to be they in the high volume of concurrency, if they have these issues, they see their insert application fail a lot, and the application has to change and do the retry and all that stuff. So with this on, with DB2 automatically try the retry before it fail, and then they see that it's increased their insert success rate, and it also reduced the headache of the DBA and application programmer to figure out what the insert application failed. To help with the serviceability, and we put in more statistic data that to show if you have a conditional lock failure, and then also if you do have unconditional lock failure, how many times we tried it with unconditional. So this way will give a better idea of in the system when you have run concurrently applications on what is going on, and if there's anything that we need to address. So that was the part that we're talking about first lesson that we learned, that customers seeing the message and that doesn't tell them much about what the message is saying and what's the real problem is. So after that, we're going to talk about things like, okay, so it's having a hard time to managing. I have no idea what's going on with the data and things like that. So for all that things that we were going to talk about, we have to look at what is our cross-partition search algorithm, right? So for PPG cross-partition algorithm, in version 12, we break the original or the traditional cross-partition algorithm. We used to be before version 12, we are one direction process. So you either searching forward or you searching, and then after when you hit the end, you kind of wrap around and move on to the previous partition where you start targeting partition. So in version 12, DB2 brought this traditional cross-partition search algorithm, and we introduced we call bi-directional. What it means is that you either searching forward in the ascending order of the partition number, or you search backwards on the descending search partition sequence number. The whole idea of doing a bi-directional is try to reduce the contention. So, as I'm saying is that you go to the target. If target partition where that cluster index doesn't help and that partition is full, then now we have to move on to others. So instead of everybody going to the same direction, now we're going to bi-direction. So that way we can spread it out, that search. It is randomly select, but it's not specifically to certain time frame. We're going to talk about that. It's for every row that we insert, we either pick ascending or we pick descending. So we're going to talk about what's the difference between two. And then first of all, let's look at what ascending sequence is. So like I say, we start with one partition where that index goes, and we go forward. When you hit the end, we're going back to from, which is 1 and 2, which is the same example that I showed earlier, and then we go to the 2. Right? And when we reach that, and then we know every partition is full because we couldn't find any row for it, then we're gonna add a new partition. So what we have improved in version 13 is to achieve higher performance. In this example, we can see that each partition is full, but before you're adding a new partition, every thread that needs to come in and do the insert, it needs to go through the process to learn that partition, does any partition has free space. So every thread, every record that you come in, if it turn out to be ascending order sequence, it has to learn that. So in version 13, the optimization in the place is to prevent every thread to searching through. It seems like it's overhead that you can really save, right? I mean, every thread comes in. If you know the partition is full, why bother, right? You just move on. So we put in the optimization in there and to track those information in memory. And then this tracking, it's in every data sharing member. It's not crossing whatever the data sharing member learned. It doesn't cross over because we're trying to save that overhead of broadcasting this information. Especially this information is very volatile because if you have an application that running insert delete concurrently, then you could, this moment the partition is full, next moment that partition may be not full anymore. So we don't want to spend overhead just to processing this across the different data sharing members. So saying that, we put in the optimization in this data sharing member, and we learn when the partition is full. Based on our internal testing, we improve this search in performance. It's a lot with very high performance improvement, and especially if you're random, because random is the one that we're going to be going through different partition and searching different places. So we achieve a very high performance improvement on that. Because earlier I said that the information is very volatile because you have full next one if you're running application has a delete. So because of that, then the workload balance between insert and delete operation is very important. It's essential in order to take this advantage of this improvement. Because try to avoid that running your workload like, okay, one member is all purely insert and the other member purely delete, because then you know that if you space reuse is very concerned, then the member that purely running the inserts, then you also know that all the partitions full because he doesn't search anymore, he just skip. And then delete on the other member, delete all, then you know that there's not enough information to tell the insert application saying, hey, there actually some delete on the other data sharing member. So balance workload between insert and delete is essential, because once one thread learns, the next thread will knows that not the delete is happening, and you will be reusing the space properly. So that was the ascending sequence. So now let's look at the descending sequence. It's the same thing that we start with one partition based on your cluster index. Now we're going to go the other direction, right? So we're going to go n-1 until we hit to the 1. So the big point here is that once we hit the 1, so where's my next one, right? So the next one today will go to what is your last defined partition. So in this example here, that most of the partition up in the front of table space are full, but you got a bunch of empty at the end, right? And so when the last physical partition is empty, so we're going to go, after we're searching backwards, we're going to go to that last partition. And you're going to say, well, which is a good one, right? Because it is a partition's empty. Once that gets there, then we're going to fill out the partition. And we're going to, if it's your, depends on if your key sequence, if it's a sequential, then you probably continue to fill out your last partition, and the search will be very fast. Your insert will be very fast. However, at the end of that, when you fill out the last partition, the insert comes in, it's the same thing again, right? So as I mentioned, it's randomly select whether you use ascending or you use a descending. So now you have decision to make. So now if it's ascending, we're going to go back to the 1 and we're going to move forward. And if it's descending, we're going to go, and then when we're going forward, we find something, of course, eventually we'll find the first non-empty partition and put your row there. And then if it's descending, we're going to go search backwards. So you say, well, descending is a great thing because once I search backwards, I find an empty partition right away, and now I'm going to put my row there. And that's perfect, right? And so depends on afterwards, however your application, what the key is, you could probably start fill into this 2 partition based on where the either your subsequent insert is closer to the sequence key closer to the first empty partition or the one before underneath the last one. However, if we put some sprinkle on top of this situation, so talked about earlier that we have partition lock failure. So if there's something, if you go into any of those parts and then that you couldn't get in, even though there's a lot of space in there, and just imagine that you could be still going forward search or backward search, and then if you go forward search, you're going to find another empty partition, or even backward search, you find another empty partition, and then you can start filling in those. So at that situation could be coming to at the end of those few empty partitions that you have few row here and few row there. So in version 12, when we decide to do this bi-direction search and causing all this situation, the side effect of this backward search, it is really designed for beneficial to some niche use case. There's one use case that it's really important to go through and to reduce the contention. This is what we come with the design with that. But once you start sprinkling into those few row here, few rows on some of the empty partitions, then that's what part of that I mentioned earlier, that what we learned is DBA say, well, it's real hard for me to manage in space because I have no idea how many space I already have. And then because all those empty partition, once you put in some rows in there, depends on how much space I need to extend into each partition. So in order to reclaim those, and now I have to reorder again and pushing all the data to front of the table space, and then leaving the empty partition in the air. So the takeaway here, it's not saying that it is a bad thing to have empty partition at the end of your table space. As I explained earlier, that the example we're seeing, it's really not a bad thing at all, because for the insert performance perspective, it's good you have some space, and then when you get into the partition, there's a lot of space you can just insert to it. But some of the DBA was like, well, it's sparing around, and it's real hard to understand what's going on, because externally, all you can see is that I have some empty partition that just a few records in there. So the takeaway is that we just want to understand this situation. It is not a bad thing. Sometimes we use that to tell customers, adding a couple more partition at the empty partition at the end just to, help with the insert performance. And so you allocate space ahead of time. So it's not a bad thing, but some of the customers really just say that it's just too difficult to manage and to understand. So in version 13, we improve on this. We're trying to make the situation a little bit better. So we're still doing the same thing as we're searching backwards. And when we get to the end of the partition 1, now we have better idea of what is your last non-empty partition, and then what is the actually last partition, right? So instead of going to say, oh, blindly to my last defined partition, now we know that end partition is where you are non-empty, and we're going to go to the last non-empty partition plus 1. Like I said earlier, we're using RTS information to determine this decision. So if your last non-empty partition are very empty, in my chart here, my slide here, it looks like it's pretty full. So going to n plus 1 it make more sense. But if your last non-empty partition is very empty, just like earlier, if you just have few rows in the empty partition, then we will go to the last non-empty partition, right? And so with this, now the idea is that the change intend to keep the trailing empty partition at the end of the table space. So that way, you don't have to run or if there's a scattering rows in those, and then you're trying to, organize them up to the front. So the empty still stay empty. We try to stay empty as much as we can. And then we try to fill out, as traditional PPG idea is that you fill out the last partition and you move forward. For this case that DB2 does not have a non-empty partition tracker, because in order to learn this, we have to learn through the time. Through the insert process, we need to know where the last partition is actually non-empty and how much non-empty is there. And we also need to rely on RTS information. And so if RTS information is not available, then definitely we still have to follow what we think the best traditionally. So we were still going to go to the last partition. But takeaway, again, is like we're trying to keep empty partition at the end, but we may not be perfect at all time. Depends on what information we have on hand. Wow. So we quickly went through this PPG, and it's a lot of information that I just talked about it. And then it's the situation that you really need to think about it, and maybe you don't encounter this situation at all. And maybe you see it and you're very familiar with that. But anyway, all these details, I hope you catch it all. But if you don't, like I said, I will provide the PDF at the end, and you can come back and reference and try to see what I was trying to say. But what I'm hoping that you can capture, you just have to remember the key points. We do have an improvement on version 13 for PPG that to improve the insert transaction successful rate, and we do retry partition if they failed, and we do have a better performance for random inserts because we skip searching the 4 partitions. So those are the kind of things that you just have to remember at the high level, and then when you need it, you can come back and look at the chart to understand what I was trying to say. So now we're done with that first topic. Are we ready to go to the next topic? So what we're going to talk about in the next one is we're going to talk about conversion. And earlier that we had the poll, and see people still have some old styles of table space or classic style space table space. So we're going to go talk about what you can do on those. And just to remind everyone, just in case you forgot what pending outer is all about, is that you'll issue the outer statement that you want to convert from one type of table space to the other, but actual change of the structure of the object will not happen until subsequent reorg. Okay. So just a quick review, since you still have a simple, the syntax, we're just going to go through the review of syntax how you're going to convert those objects. For simple table space, we'll convert it using outer table space and with max partition keywords. And that will go get, after subsequent reorg, you're going to convert that simple to PPG table space. It has to be on single. If you're using this syntax, it's a single table in the table space that you can convert. We deprecated simple early on in this series, which is version 9 when we introduced UTS. You still can continue using it. There's nothing wrong with it. We still support it. Just that we don't build anything new to the table space anymore. Then you have that classic partition table space, which is you're using the same outer table space statement, but using set size, because in classic partition, you already have a range, a keyword defined it. So then now you just need to be using set size. And the reason is that in UTS PBR, internally, the data are organized with the segment fashions instead of linear. And that will convert you to UTS with the partition by range is PBR. Classic is deprecated also. You know, we're trying to all deprecate those. And like I say, in the future direction, still UTS and PPG and PBR RPN. So because we deliver this conversion in early ages of the conversion life, so we just say, okay, we just need to get classic partition into the PBR UTS. But we didn't introduce PBR RPN until 12. So what we have done is that in order for you to go all classic partition to UTS RPN, PBR RPN, you need to convert it to UTS first, and then you convert it to RPN, PBR RPN using outer table space page number relative, and followed by a reorder. And again, that is in become our future direction of the table space, and then it's available. The conversion is available in early version 12 and 500. Then similar to segmented table space, we have similar to the simple that we're using outer table space of max partition, and then convert it to PBR, to PPG. I'm sorry, to PPG. And segmented table space also deprecated, but some of them still using it. It's a time to convert them and plan ahead. I think most of the customers waiting for our new delivery, which is what we done in, is when you have a multiple table in your table space. And this is what's delivered with function level 508. And notice that because you have a multiple table, no longer using a keyword for the table space that signify what the type of the table space in UTS. Now, because you have multiple tables on your outer table space statements on the syntax, you need to indicate which table moved to which table space. And so in order to convert this multiple table space to a single, each segment, each table goes in the single PPG table space. First of all, you have to define this, you have to create this PPG table space first. And you must create it with define null, and then you don't have a data set behind it. And it's max partition 1. And I can talk about why we're doing that, because we need to reorder to grow partition if it needs to. Okay. And then you have, for each table, in this example, each table that we have 3 tables, so we create 3 PPG table space. And then when you create that, now you issue your outer. You have to create those table space first, because remember that syntax is moving from one table to table space. That table space must be defined first. And then you execute your outer statement. You can do the way that, okay, I don't have a time to do all the at once. I just need to do one table at a time, and you want to plan it out. That's okay too. You can do one outer, one reorder this weekend, just move one table, and next weekend you do another table, and so on, because we've seen in the field before that customer for the multiple tables in the segmented table space, some of them, they have 1,000 tables. So there's just no way that they can be able to move all 1,000 tables in one go. So they can do, batch of things. So you can put them all together, or you can, do one at a time. You can, once you've done that, you run reorder on the source table space, and then just move reorder, just gonna move your table data to where that you specify. Of course, you know, once you move from segment table space to multiple table to a single table space in PBG, your package and cache statement most likely going to be invalidated. So we invalidate. So once you got to the application accessing a new table space, you will have you know, rebind and bind, automatically rebind and bind. So here's just an example that we talk about it. So created, you use defino and with max partition 1, and then the outer you just specify which table moving to which table space and so on. So that's talk about that, all the, you know, deprecated object and how you help yourself to convert it from one object to the to those UTS table space. Now we're going to talk about is within UTS itself. So we are converting PBG to PBR, and why are we doing that? So earlier, remember that we just say that the reasoning being of this is that large PBG table space may be more suitable or easier to manage if it is in a range partition fashions, right? So a customer that has migrated deprecated object, you know, in the early on of the DB2 release, and then move it to PBG. And then they have been facing this challenge because now PBG table space has grown so large that it's hard to manage. And in order for them to reverse that decision or changing that decision again, they require them to convert for PBG to PBR. They need to plan ahead, and they most likely before this function, they will have to drop the table, create a new table, unload. And if you have view and all that, you gotta render that. I remember in one of the section, the customer talk about how they're doing converting their PBG to PBR. And so it's really a long planning and also the long outage that they have to do in order for this to happen. So now in the Db2 we deliver this capability to convert PBG to PBR, and building on top of the pending outer structures, and it provides a high availability for the this type of conversion. It is another major step for us in the object conversion support, and building on top of the pending outer support with the reorg, you know, we can convert this within UTS to UTS table space. So it is really a big change for us. One thing that to point out is that remember that we talked about that PBR RPN is DB2 future strategic partition table space. Therefore, the conversion default is to PBR RPN. So if you convert, you already have PBG today, you wanted to convert, it will be PBR RPN table space. Look at the syntax, right? So the syntax here, remember all previous syntax we're talking about outer table space, and this particular syntax is outer table. The reason is because we need to specify what is your key range for this new PBR RPN table space. The key range here for the UTS for its table control partitioning, that means that your definition of key range is defined as a table. That's why you see a outer table instead of outer table space. And the picture on the left side here, I purposely to show that if you have a partition by growth, and which is 3 partition, you do not have to convert to PBR RPN with the limit to 3 partition only, because you need to define your keys. So you could have multiple more partition than your PBG. So you don't have to be one-to-one correspond to each between 2 table space. The challenge in here that I can see, and then you know, just maybe once you start getting to it, you can tell me. See, the challenging I think is that in order for you to convert from PBG to PBR, you need to find your existing column in your original PBG table space, and that to make it as your partitioning range key, right? So that means you will be able to find out something that's meaningful enough for you to break your data into the different partitions. Okay. So I talk about that PBG to PBR is pending outer because it is pending outer building on top of pending outer structures. The differences here is that if you don't have a data set with it underneath of your PBG table space, meaning you create it with defined node and then you don't really have any data, then it doesn't have to be a pending outer, meaning you do outer and then you wait for. We could be immediate outer, meaning once you outer it become a PBR RPN. But I think most of the time that's not going to apply to it, because if you have usually if you create a PBG, you probably already have a table space to it, data associated with it, so it's not going to be immediate outer anymore. Well, the real must be run on entire whole table space and has to be share levels reference or share level change. I think this is similar to all the pending outer that we have for other objects. If you remember that we have one ZPump that created, I believe it's version 12, that is, some of the customer told us was that they wanted to be able, some of the outers, like immediate outer that we have, they would like to say, oh, I need to plan ahead, I'm going to do the outer, but I really don't want to materialize my data until much later. So we gave the ZPump to say, well, for the ZPump, you can say, oh, I always want my outer to be pending, or all my outer to be immediate for some of the outer that we support. But in this case here, it doesn't apply, because we always need pending outer, because you have to do your outer and you do a reorg in order to convert that data. Convert to
Francis, we have a question in from Dean. He says, will we ever be able to rename a table space in DB2 for C?
we talked about that before. I think there's some function, but I don't really have a good answer for you at this point, because internally in development team, we talk about this a lot, and we're trying to improve it in some fashions, but not many. That is not really our short-term immediate action to take.
Okay, thank you.
Okay. So converting to partition to the PBR RPN, when you convert, the attributes of table space are exactly the same. You just move on. The only thing that I was saying earlier is that you don't have to be one-to-one correspond to the partitions, but you can. The attributes are some. The newly added partition attribute, when you grow, when you spread it into the range partition, the newly partition is still going to inherit from the previous. So at table space level, there's no change. And the beauty of this conversion is that there's no table OBID changes, there's no the DBID changes and all that stuff. Not like if you don't do pending outer, you will have to create different table space, different ID, and then you have to manage in your application, make sure that the name is okay. And I think that's where the question about is, can I just rename it and be similar, and I don't have to worry about it. So those are kind of things that the pending outer in this conversion or brand new, you don't have to worry about that. Using this, there's no OBID changes, and the name is stay the same. Right? It's just the internal underneath of the data structures changed. Then I also mentioned about it is table control partitioning, because UTS, the table range, the key range of each partition is a table level, and so that it's something that we call table range control partitioning, and so you don't really have to create PI if you don't want to. And it has to be EA, because we expect that PBR RPN is something that you're going to be big, so we need to extend addressability. In this part of it, remember that PBG is MPI's non-partitioning index. So once you convert, those index goes with the table space and then go with the table, and then it's converted to also MPI. Like I said, that it's table control partitioning, so we don't need to create PI just to access those range of partition. So, but if you in your application you feel like creating a PI or even a gypsy, it's meaningful and useful. Once you convert, then you can create that one. Then after it become a PBR RPN. Access path I talked about earlier, that you're going to be invalidated because now your access path might be changed because it used to be our PPG has linear multiple partitions, and now you have PPR or RPN. You can probably have better access path because now you have a range of the data to reside. But we will be tolerated by and read by, so you have no issue with that. Of course, we are providing this ability, and maybe everyone, some people is going to say, well, so am I going to can I convert my catalog table? And the answer is no. You cannot convert DB2 catalog table from PPG to PPR. At this point, most of the catalog table in DB2 is still PPG with max partition 1. You can get up to 256 gig. I think that's what every catalog table now, but you cannot convert them. Of course, not global temp table, we don't support with that. No hash table. I hope you don't. I don't know how many people are still using it. Hash table. We don't hear much of customers using it, and that's why it's another deprecated object. And then also, if you have a clone is another thing, like everything else, that you need to drop the clone first before you can convert. And so all the conversion, and same thing as outer. The table cannot contain LOB and XML. At this point, we don't support that PPG table has a LOB XML column for this conversion. But we did not find that it's a major issue because through our development cycle, we work with our sponsor users, and most of the sponsor users mentioned that it's no problem because that's not a roadblock for them to convert their large PPG to PBRs because of their most large PPG table space doesn't have a lot of XML columns. And high limit key for the last partition is enforced because now you are in the range partition. And what it means is that, remember the syntax that I showed earlier? On your last partition here, you must indicate what is the highest value, maximum value. So if it's ascending key, you need to say max value. The reason being is that we want to make sure that all the data can, if you, based on your range key, limit key range definition, we want to make sure all the data can go into. So if that data conversion, will, at least if it doesn't part of your limit key, at least go into your last partition. So it's enforced and you must use max value. And then if it's descending key, you need to use minimum value. So same thing with every other pending outers, that you cannot do many pending outer in one go. So you need to make sure that you're doing one pending outer at a time. And then data tablespace must be able to access, right? So if it's in restricted state, that you're not going to be able to do that also. So recover, it's similar to every other pending outer. You know, I hope I showed this picture that clear enough. Once you reorder and convert your table space to a different type, you can do your recover, you know, any point in time to current whatever after that period. That's no problem. What you cannot do is that once you materialize, we try to recover back to the previous type of table space. So it's not going to happen. The idea is that we think that you're just going to convert to UTS, and that's the direction we're going to go, and we should go forward from that point on. Okay. So that'll quickly go through the conversion process. And then, like I say, you know, it's really a big deal for us, and for especially for PPG to PBR conversion, it's a very welcome feature that we deliver in version 13. Many customers waiting for it, and they're very happy that we'll be able to deliver that. Through our development cycle, we work with many different sponsor users, and they're really happy with this big enhancement, provide them their better availability and easier to use. So it is a great deal for us, and we spend a lot of time for delivering that. Just because UTS to UTS, it's a lot of each internal structures the same, but you know, the definition and all that, we really have to consider a lot. So now we're done with the two of that. Now let's look at the application. This is another exciting project that I work with, and I was really happy to share this with everyone. So first thing we can talk about that, what is a good feature? Why is so good about in these features? We need to know what was the pain point that DBA and the application programmer is experiencing, right? So most of the things that first thing they say is is that difficult to managing lacking serialization among application running at the environment at the given time. Okay? So different application that has different characteristic, and then there's no way to express what I want the priority of this application when it comes to the lock contention, right? So how long do I wait for the lock, or I don't really want a contention on the lock, I don't want to wait, and how do I avoid that? So it is a challenge for DBA or application programmer to design the application and then according to all this situation and avoid the contention, because sometimes you don't know any other applications running until you're running in production, right? And then you don't find out this lock contention until all the applications are running together. And so once you find that, then discover that in your production system, most of the time this lock contention issue is so hard to tackle, and either you're changing your application, or maybe alternatively you just run it in different DB2 subsystem to avoid this contention. So if you can do that, that's great. I mean, but if there's case that you just can't do it, right? So, and also the DB2 provide you a ZPROM to say, okay, well, when you are waiting for the lock, here's the ZPROM. You can tell DB2 that how long do I wait for before I fail this application. So with this timeout ZPROM value that you can specify, and that will give you a little bit of control. However, this ZPROM is at the subsystem level, and that means that all the applications that run on the same subsystem has the same timeout value, right? So if there's a business critical application that you cannot fail, and you need to wait for the longer to get the lock and be able to be successful, then you're gonna say, okay, I need to changing this ZPROM value to be higher, that to accommodate this situation, because I really need to go through this, this application, and it cannot fail, right? So, but then all the application running on this subsystem, if you have the application that needs a favor of that, if I fail, then I want to fail fast. And when you run the application list now, you're not going to fail fast, because whatever that ZPROM value is setting, maybe 30 seconds, maybe 60 seconds, or maybe 1 second, you're just going to suffer based on that. So this is really hard for DBA or application programmer to either tackle around it or to design around it. So besides waiting for the lock to lock timeout, we also have the issue about deadlock. So the deadlock meaning that the situation where one thread is holding the lock and waiting for the other lock, and that lock was holding by the other thread. So we are in this looping circle that we never can get out of it. So when we come out in this situation, DB2 decided deadlock victims based on many different factors, and it's internally decided. And the user externally has no way to influence this decision at all. And so one of the common cases that we've been seeing and customer has been talking about in front of to the development team is that when there's a DDL and DML running together in parallel, and that DDL needs to accessing the object that holding the lock, that you cannot get through, right? So if they have this deadlock situation happens when DDLs were holding, waiting for the lock that DML is running is holding, and then DML is waiting for the lock, and then when they have a deadlock situations, DBAs say, I have this DDL that needs to go through, and then it's very critical schema change, and I cannot tell how does DB2 internally will decide whether the DDL thread that's going to be a victim or the application going to victim. And then, so it's really hard for them to control. But that DDL must be going through and cannot be a victim of this deadlock. And because this critical schema change, it has to be gone through. So in this case, there's just no way of doing that externally. So in version 13, we solved the problem and giving user another flexibility and to provide this availability and make the application run more consistently. So in version 13 function level 500 or higher, there's a special register called currently locked timeout, which can be used in application level and specify what the timeout value is. And this value, whatever you specify in this value, IRM is going to take this register values over your ZPROM values, right? So when this application runs, Db2 IRM look at this value and then decide whether how much longer that you need to wait for the lock before you run out of timeout. For the example that we just talked about, it where the application needs to fail and fail fast behavior, when you are running with the business critical application, in that ZPROM value is much higher, but then this particular application need to fail fast and then knows that don't want to wait for that ZPROM values. Now you can set this as special register. You can set it to say, oh no, wait, once I come to the contention with the lock, just don't wait and fail me. So similar things. Here's some example possible value that you can specify that I put it on the slides. And that for critical application that need to wait longer, maybe that your ZPROM can set it to, maybe 10 seconds for most of the applications. But for this particular critical applications, that if I have a lock contention, I want to wait longer than 10 seconds, then you can use a special register to specify the value that you want to wait. So kind of now give you flexibility to control this timeout values at the application level, right? And so you provide higher availability and usability. Because of these changes, we want to make sure that the ZPROM that you can change on the IRM ZPROM, now it's online changeable, because this is it used to be offline, so it doesn't make sense that you can have set this application timeout intervals, and then now you have to bring down your Db2 before you can changing your IRM timeout ZPROMs. So now IRM ZPROM changes can be online changeable now. To provide the high availability and the change of IRM timeout ZPROM, we also worry about that now the application programmer may now know what will be the standard of the timeout intervals in the system, and so you may be design some current lock timeout with the very high values. So now we give a DBA a better control with the new ZPROM, and that's called SPREG lock timeout max. That's a special register lock timeout max parameter, and in this parameter you can set the ZPROM and give it to say, well, what is my maximum value? So because remember on the first bullet of the slide is that the value of this current lock timeout could be up to 32K. So just in case that application programmer want to make sure the application goes through and then setting it too high, that's going to wait forever. So this is ZPROM is giving a DBA that a flexibility that you can just say, okay, all the application run, even though I know that my IRM ZPROM is 10 seconds, but you cannot specify more than 5 minutes or something like that. So this is a ZPROM to give you a better control of that, just in case the application sets too high, and then so DBA has control of that. Okay. Then earlier we talked about that there's no influence on how decision that Db2 makes when it comes to deadlock situation. So now here we are, similar to the lock timeout. Now we go giving a global variable, which is that deadlock resolution priority. This is the same thing, similar idea of timeout, lock timeout interval. This is now you can set this and then to influence Db2 when it comes to deadlock resolution and which application to pick as a victim. So now we're giving that granularity of the control down to the application now. And so instead of the Db2 internally decide that, the higher value of the global variable, the higher priority to get resource. So that means when the two threads are in the deadlock situation, the application that has a higher value will have a better way of retrieving the successful rate instead of the one with the lower level. So meaning that most likely the lower value of this ZPROMs and this global, the lower value setting on this global variable will be most likely the victim of the deadlock. So back to the example that I gave earlier about the DDL case. So if a DDL comes with a deadlock and you say this is really a very important for me to go through this schema changes. So now here you can set the job that you run for the DDL with the higher resource, with the higher values, so then you will get a better resource. At the end of this features for current timeout value and also the deadlock global variables, you both can use it in profile, because I know a lot of customers now, they are using profile to control their application. So they both profile support both of them, and then they both are available in function level 500. And this features then can provide the higher availability and also application stability. Now you have better control, like when the deadlock happens, this application is going to be more successful. Go through much better than the other application. And if it's a timeout, unlikely this particular application will get timeout, and so on. So it gives you a better controls and also application level, at the application level, and give you application stability. Okay. Of course, that if we wanted to do that, we want to make sure that if you actually truly timeout, we want to give you a true reason of what the value that DB2 use and where does that come from. So in this DSNT 376, I remember earlier I also show you in a PBG tablespace timeout messages. It's the same thing here, and just an example, probably easier to see is like now you're going to see who's your holder, who's your where's the requester using, where the timeout value from. It's from special register, and the value using was 10, and then the holder is using a timeout of 60, and then it's from IRL MZ pump. So that can give you some idea that, oh, okay, now how you're going to adjust your application, and so you know that you could set it better, or if this is the behavior that you really wanted. Okay. Of course, serviceability wise, we will never forget that. We're always going to put more serviceability for us to know what's going on. So here, just a list of the example, the serviceability that we put into the trace record. So on the trace record, you will see more about give you a better idea what's going on in the system. Okay. So I went through very quickly, and I really hope that you're getting of that. But here's a quick high-level summary. You just have to remember that we do have a better performance for PBR RPN, and then PBR RPN become our default partition table space if you comes to version 13, right? And then we have PBG improvement, as I talked about earlier, about cross-partition search. We have performance improvement. Then we have this object conversion that now you can do PBG to PBR RPN. So those are kind of easier for you to do in the object conversion cases. Then the two great deal of application control where that give you more granularity control from the system level down to the application level. You have a special register and global variable to use, and then both of them can be used in the profile. The profile table also control this. So all that's the information here, just a high level, and then if you detail, you could always go back to our Redbook. This release of Redbook is composed by all the development and also the SMEs. So you could find a lot of good details in there, and then every developer that contribute to all the features that we done in version 13, put in their contribution into this Redbook. So the Redbook, it's pretty cool, and we have to review it, and it's very good. And if not, then you always have DB2 13 for 0, so you can find all that details. If you still need any help, you can either open your, go through your normal channel to DB2 PMR process and ask questions, or you can always send me an email, and I can answer you as much as I can. And that's all I have. I hope.
Oh, that's a lot.
Yeah. Sorry.
So that's great, Francis. We kind of were aiming for quarter after the hour, but I noticed that virtually no one is left. So that just shows you how important the information has been. Let me just take back control here quickly, and
Okay, great. Thank you.
I'll do the final wrap up and ask our famous final question, which is, just let me go forward here. And the question is, did you learn anything today? And I'm guessing that this would be a pretty high number in terms of everybody learning something. Always is when it's a new release, and this is fantastic information for people. So with that, I'm going to share the results, and 100% of our audience learned something today.
Thank you, everyone.
Thank you, Francis. That was a lot of information. We hope you'll come back and visit with us again on the Db2Night Show. We had a lot of great information there. And with that in mind, we are getting into the summertime. Have a great weekend, everyone. Have a great summer. Hope to see you at upcoming IDUG conferences and through other things that we do on the DB2 community. And as always, the Night Show is here to help and see what we can do. If you've got any ideas for future shows, send me an email or something of that nature, and we'd be happy to try to accommodate. So with that, I'm going to cue the music and wish everyone again a great weekend, a great summer, and we'll see you in the fall on the Db2 Night Show. All right. Thanks again, Francis. Bye-bye.
Thank you. Bye.